All right, so let me just start off here. Lorenzo purchased a box of cereal and some strawberries at the grocery store. Lorenzo paid $2 for the box of cereal and $1.90 per pound for the strawberries. If Lorenzo paid a total of $9.60 for the box of cereal and the strawberries, which of the following equations can be used to find P, the number of pounds of strawberries Lorenzo purchased? A. Looks like it, right? Because 2 is like a constant, right? It doesn't change or anything. It's always going to be $2. And then $1.90 per pound. Yeah, we have our $1.90 and then we have our variable here. Quick little, this problem should be pretty easy. Hopefully I don't have to explain it that much, but yeah, we have, so every pound of strawberry is $1.90, and then we're adding $2 to that, and that equals to like $9.60. Okay. These other ones don't really make much sense. Like, why are we subtracting? This one just gets it flipped. So, yeah. Moving on with that one. This one we can use Desmos. Plus 30. And just F of 2. So, yeah. So we got 80 there. The graph shows the estimated value in dollars of a tablet as a function of the number of months since it was purchased. What is the best interpretation of the y-intercept? When it was purchased. Right, the value when it was purchased. Right, I mean, intuitively it should make sense to you. It's the y-intercept is when x is 0, and if x is 0, that means it's 0 months after it was purchased. So yeah, it would be the estimated value of the tablet when it was purchased. Yeah, so it's this one. Yeah, we can just graph this. So actually, this is a good demo here. Let me show you guys something real quick. Something that you should pick up on. If we graph this as it is, it won't show up on Desmos because Desmos can only graph like x and y pretty much. But if you can just change it to x and it'll be the same thing, because like it doesn't say anything like p is a constant or anything, so we can just set it equal to x pretty much. And now we just choose our answer here, which is 4. So it's B. Okay. Triangles EFG and JKL are congruent where EFG corresponds to JK and L. Respectively, the measures of angle E is 45 and the measure of angle F is 20. What is the measure of angle J? So if they're congruent, they have the same, like all their angles are pretty much the same. So E corresponds to J and E is 45. So that means that J is 45. Okay. So during the first part of an experiment, a ball was launched from a 7-foot tall platform. The graph shows the height y in feet of the ball x seconds after it was launched during the first part of the experiment. Okay. During the second part of the experiment, the ball was launched the same way, but from a platform that is 2 feet shorter than the first platform. Which of the following graphs could represent the height y in feet of the ball x seconds after it was launched during the second part of the experiment? So I think, so it's just asking us, like, at the y-intercept, it should be 5, right? It should be 5 feet. Because the y-intercept, again, is like same logic that I used in the other question with the tablet, right? So we should find a y-intercept that's about 5. This one's like below 4, so it's not this one. Yeah, it's this one. It's 5. Okay. And then these other two are way higher, right? So it is not that. Go on to 7. The ratio of x to y is equivalent to the ratio 9 to 5. If the value of x is 162, what is the value of y? All right, so when we say the ratio is like 9 to 5, we're essentially saying like it's a fraction form, right? That's what a ratio is, 9 over 5. And this is equivalent to 162 over y, right? We don't know what our y is. we can do it like this. So we can solve it like this, and we get that our y is 90. Okay, and what this will do is, if we do 162 over 90, it will get us 9 over 5. Okay, so we're essentially trying to find the y value that gets us the same ratio, which is 90, right? You can also do this via regression, which, if you guys followed the James Liu video, you should know how to do this, but it also gets you the same answer, which is 90. Let's close out of that. At a state fair, attendees can win tokens that are worth a different number of points depending on the shape. One attendee won S square tokens and C circle tokens worth that amount of points. The equation represents the situation. How many more points is a circle token worth than a square token? 10, right? A circle token is worth 90 points. Square one is 80. 90 minus 80 is 10. What is the solution? Let me just graph that. X plus 9, x minus 9, x plus 9, that's equal to 7. Our solution is, Desmos isn't telling me, it's 16. So the equation 12t plus b equals c relates the variables which of the following correctly expresses the value of c minus b in terms of t. So it's saying what is c minus b pretty much. Oh. Okay, so I have to kind of just write it on Desmos because I don't have notebook paper, but just bring over this b to this other side, right? So subtract b, and then what you'll have over here is c minus b. All right, because you subtracted this, so that means you have to bring it over to this side, right? And so what you're left with is c minus b, exactly what you're looking for, and that is just equal to 12t. So it's 12t. What is an x-coordinate of an x-intercept of the graph of... Well, one of them can be... you can... I can already tell it's like one of them is like -5, -4. Another one's 14. Because you can just, look at these, 3 roots, I guess. But you can also just graph it. So let me do just that. X plus 5, x plus 4. Yeah, I'm gonna just say, what is an x coordinate of an x? I'm gonna just say like 14, because I feel like it's the prettiest one. All these other ones are like negative. Let me just check though if I wrote this correctly. Yeah, okay. And then, this one we just plug in our equation here. 1 over 4 minus x, square that, plus 11 over 4. Then it's asking us what is 1 over 4. It's 2.75. Can that be turned into a fraction? Okay, yeah, it can. 11 over 4. So that is our answer. Simple enough. In a circle equation, has the equation this, which of the following gives the center of the circle and its radius? Okay, so you should know the basics of a center, or not, you should know the basics of a circle equation, but if you don't, it's the circle equation is like this. Okay, so you have this, and it's equal to r squared. Your h and your h and your k are your x and y coordinates for your center. Okay, so in this instance, whatever h is, it's actually going to be the negative of it. Okay, so just whenever you're looking at the center coordinates, look at the sign right before that. If it's negative, it's actually positive. If it's negative, it's actually positive. Or wait, yeah. If it's negative, it's positive, but if it's positive, it's negative. Okay, and same goes for y. So like if it was, in this case, -13, our actual x coordinate for the center is +13, if that makes sense. And so what that would mean is our center y coordinate is +k. Okay, so yeah, hopefully that makes sense. And our radius here, you may think it's 64, but no, that's the number when it's fully squared. Okay, so what you have to do in this situation is just square root 64, which is just 8. So it's going to be, the center is 13k, and our radius is 8. So hopefully I explained that well enough. But yeah. So circle has a radius of 2.1 inches. The area of the circle is that amount of inches, where b is a constant. What is the value of b? Okay, so circle, the area of a circle is pi r squared. Let me just write r here. So r is 2.1. Right, and you'll see we'll graph it actually. That's kind of a neat thing, by the way, if you didn't know how to do that. So r is 2.1. I would just get rid of it though. And then our equation for our circle here is this, right? And this is equal to this format. So what we're essentially saying to Desmos here is find the answer to this, and then convert it into this. Not necessarily convert it, but find the b that makes this equal to this, right? Which is the format that it wants. It wants us to find this format, right? Like b pi. So we're just essentially saying like, what value of b gets us this, and it's 4.41. Or you can just realize you can just like square. You can square 2.1, which is 4.41. Right, so nothing too fancy. I kind of made it a little more complicated. This is like, I feel like the faster way of doing it, but it's whatever you want to do. So 4.41. Let's move on. So during a study, the temperature in degrees Celsius of the air in a chamber was recorded to the nearest integer at certain times. The scatter plot shows the recorded temperature y in Celsius. Exponents, okay. What was the average rate of change? C per minute from x to 5. Okay. So it's basically saying like, what's the slope? So from 5 to 7. Oh, it's counting in increments of 2. So 2, 4, 6, 8, 10. 1, 2. So 10 over 2 is 5. Okay. But if you didn't know how to do that, you can also use a table regression. So you can just plot in your points. So like 6, we have 5, and that looks like 14. And we have 7, and what looks to be 24. You press this button up here, and it gets us our equation, and we're told that our slope is 5. So yeah, we're correct. Let's see here. System of equations. So we just graph it. Negative 3y equals 9x minus 23. There's so many points here. Okay, so yeah, this is our x value. Let me just call it x1. 39x1 is roughly 18, so it's b. Okay, we're almost done. The function f of t, blah, 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 gives this number of bacteria in a population t minutes after an initial observation. How much time in minutes does it take for the number of bacteria in the population to double? How to zoom in? It's 790. Okay, the reason why is because once you're essentially trying to find what number makes this entire like fraction 1, which is 790, right? And 2 to the power of 1 is going to be 2, and 40,000 times 2 is double, right? But if you didn't know how to do that for whatever reason, you can just plug it in, right? So let's just say f of t. You can just plug in the equation f of t, 40,002. You can say t over 790, and you can go through each of these answer choices and pick whichever one matches. So like if we did f of 2, that is not 80,000, that's not double. But if we did 790, yeah, that's double. So we're correct on that one. I did pick B, right? Yeah, okay, I did. This one's again pretty easy. Just plug it into Desmos. 2 minus 4x. We get the value negative 2.25. So 2 minus 4, negative 2.25. We get 11. So, yep. So, a scientist studying the life cycle of dragonflies counted the number of dragonflies in a certain habitat each day for 46 days. On February 15th, there were 99 dragonflies in the habitat. The percentage increase in the number of dragonflies in the habitat from January 1st to February 15th was 12.5. How many dragonflies were in the habitat on January 1st? I got none of that through my head, so let me read this again. So, certain habitat each day for 46 days. February 15th, there was 99 dragonflies. A percent increase in the number of dragonflies from... Okay. Oh, okay. I think I know what we're doing. So, you have to kind of understand the general sort of gist of percentages. Hopefully you do, but a quick little recap. 12.5, you're supposed to convert it into a decimal, right? And then you're supposed to add 1 because whatever number it is, whatever number of dragonflies we had on January 1st, we're multiplying it by this to get to 99, right? Because we're increasing by 12.5%. And this is pretty much 12.5% in percentage form. Or not in percentage form, in decimal form, if that makes sense. We're adding it to the 1, right, which is our dragonflies of whatever number it is, right? So how you're supposed to do this via algebra is you're supposed to like call the amount of flies you had here like x1, and you're supposed to do like this, right? And then you say like it's equal to 99, and then you find it, which I think you actually can like this. Oh, no, I don't think you can. Okay, so no, you can. So it'll be 88, or you could say like something like this. So x1% of, I'm trying to think of it via regression because I already solved it like that, but x1 percentage. Oh wait, it's gonna be something like this. So 0.5% 1 is 99. So we're saying of some number we have 112.5%. So 112.5% of some number is 99, and we're just telling Desmos what is x1, and it's 88. Okay, so that means and we proved it the other way as well, if this way doesn't make sense, but it's going to be 88, right? And that's, that should make sense. Like if you look at our answers here, this just doesn't make sense. It's way too low. So it's either between 88 and 87. Here on both methods we got 88. So yeah, it's gonna be 88. So I just wanted to show you like a regression way and like a normal way to do it. Let's see here. One solution to the given equation can be rewritten as this, where k is a constant. What is the value of k? Okay, so we're probably going to need to use a slider here. Minus 7 equals 0. So we have 2. Let me just highlight those. And this is our form factor right here of one of them. I don't know which one. So we're just going to add a slider. I like to always change my bounds to like negative 100, 100 starting off. So let's see. Okay, so we can't go negative. It becomes undefined. That makes sense. So as we move k closer, it looks like it's going further away from 4 points. So it's probably going to be this one, if I were to imagine. I just need to get to it. Oh, I need to increase my boundary. Okay. Oh, it's 120. Yeah, because it's literally the same number. Okay, so it's 120. So hopefully that makes sense. I just brought in my slider and I was trying to match it with this number. So, yeah. Shouldn't be that hard to understand for that one. The function f of x is defined as 19 more than 4 times a number x if the function is graphed in the xy plane. What is the best interpretation of the x-intercept? Okay, so the function is 19 more than 4x, right? 4 times a number. 19 more than that, so 19 plus, or you can think of it as like 4x plus 19, so 19 more than 4 times x. What is the best interpretation of the x-intercept? So the x-intercept is this number right here. Change it to fraction form. So negative 19 over 4, so when y is 0, the number is, oh yeah, it's this one, right? Because we're essentially saying when y is 0, which is correct, right? When x, when it crosses the x-intercept, that's when the y is 0. The number is negative 19 over 4. So yeah, that's exactly what we got. So it's this one, A. Which of the following expressions is equivalent to this? Okay, so very important to note here, you have to switch to degree mode. If you switch it to, if you do radians for 1, you're not going to get, the correct answer, but it's going to just look weird. So make sure you switch to degree mode. So let's see, here's sine 24 cosine 66 plus cosine 24 sine 66. We get 1. So now we can just check all our answer choices and see which one matches. Okay, so it's not that one. Try B. Okay, so it's not that one either. Nope. Cosine 66 squared plus cosine 24 squared, and that is 1 as well. And so that means we are done with this first section. I would normally, I would check over all my answer choices when I have this much time, but I'm gonna just continue on because I don't want to make this video too long. So yeah, we'll just continue on. Hopefully I got all of them correct. And just to know, I'll probably run out of time with this next section because I'm trying to explain it all, but I'm gonna go way faster in this section. So for how many of these 15 days did the battery receive 0 kilowatt hours? 6. Right. Which of the following is the slope of the line? Best fit? Okay, let me pull out the calculator. Bring out some points. So immediately I can see we have like a 0.2 and like, what is that, 5? Let's just call it 2.5. It's not exactly, but we just need some points. So then we have 3 and 7. And we get the slope of 2. So for these ones, just pick 2 points that look closely to, whole answer choices and just pick them out, put it into Desmos, make a linear regression line, and then you're done. So in a sample, 80% of the items are faulty. There are 88 faulty items in the sample. How many total items are in the sample? Okay. So you can also do this via regression. You can say 80% of some number is 88. And so Desmos will find us a number in which 80% of that number is 88. So it's 110. So again, I'm trying to go fast, but that's because this section is a little more, I need more time on those geometry questions. So -1, 25, let's see, yeah. We're just graphing it. 0, 1, 1 over 25, 2, 1 over 625. And let's see, is this yeah, it's an exponential function. So yeah, this one, 0.04, that looks to be like 1 over 25, right? 0.04. Yeah, so it's this one. Moving on. So if 8x is that, we get our x is this, 0.75, 72, 0.75, so we get 54. Okay, so for this one, we have a couple different conditions. So all you need to do is just meet the conditions, right? So for me, let's just say I set h to 3. And let's say I set like q to 2. So now let me express this equation. This is all over this. And so we get this answer. So now we need to check all of these. And whichever one is equal to this is our answer. Because they're equivalent, right? Q14. Oh, okay. It's A. I did not expect it to be that fast, but yep. So a company fills boxes with approximately 23 pounds of oranges to test the accuracy of the filling process. 344 boxes of oranges were selected at random and weighed. Based on this sample, it is estimated that the average weight of all boxes of oranges filled by the company in an 8-hour period is 23.1 pounds with an associated margin of error of 0.19 pounds. Which of the following is the best interpretation of this estimate? So this is a margin of error question, and a margin of error question is extremely easy. So margin of error is whatever, you're calculating your average, your margin of error is exactly what it sounds like. It's the error that is associated with that average. Okay, so the error can apply greater, it could be greater than or less than this number, right? So we could say like 23.1 minus 0.19, if I could write correctly. And we can say 23, actually, hold up. 23.1 plus 0.9. And so our value, whatever our margin, it's, the average isn't fully accurate. So it's between 22.91. The actual, average is between 22.91 and 23.29. So that's all you need to know for margin of error. It's always going to be the one that says, between these sets of values. So it's A, because it says it's between two set of values. This one just says it's less than or greater than. No, it's not going to be that. Okay, and then these ones don't even mention that. So it's just going to be A. This one, it should be pretty easy. Margin of error is just between two numbers. Let's graph this. X plus 6 minus 1 over 2. X plus 6 equals -8. So what is the x? That looks to be 42. Let me check if I wrote it correctly, though. Looks like I did, so let's move on. Okay, this one looks like a little more complicated, but don't be scared. It's just a simple regression one. So let's write our f of x and our g of x. Minus 27x. Okay. And now we're told that f of x times g of x is equal to this. Minus 26x to the power of 3. Minus 3x squared. And now we can just make this a regression. Okay. So we can set it equal to this, set it equal to that, and now we have to change this into a regression as well. And our B is this value, 1/9. I should say you should probably, I don't know if it'll work that well, but you don't have to do this because it'll find the answer for you regardless, but it's going to be B. Like, this is like, we're asked what is the value of B. It's 1/9. Okay. Technically, you should always do this, but it was the same regardless. So, yeah. 1/9. Get rid of all that. In the xy plane, line S passes through the point 0, 0 and is parallel to the line represented by the equation y equals that. Line S also passes through that point. For D, what is the value of D? Okay, so it gives us a point. It gives us 0, 0, and it also gives us a slope. And our slope is 18x1 for S. And the way I know that is because a line that's parallel, if you think about it, right? Let me just get rid of this. A line that's parallel is going to be a line that has the exact same slope, but different y-intercepts, so they never touch. Okay? So that's how I kind of know it's parallel. It kind of tells me that pretty much. So y1 is 18x. We're just setting a custom regression right now. And then plus b. We don't know what b is. And Desmos solves that for us. We have a point here. And so Desmos like figures it out. Because to quick little tip as well, which you should have gotten from James Liu's video, for every constant you have, or for every variable that you don't know, you should have a point for every single one of those to solve for that variable. Okay, and in here we have 1 point to solve for b. So our actual equation here is y equals 18x, or I should make it into this format actually, 18x. And now we can say at what point, what is our y value at 4, because that's what it's asking, and it's 72. So let's see. So this one's when it reaches the minimum. So we can just graph this and check. X minus 44, x minus 46. It reaches its minimum at 45, at x 45. Oh my god. We'll just skip over this one for now, because it's a bit of writing. So in a set of 4 consecutive odd integers where the integers are ordered from least to greatest, the first integer is represented by x, the product of 12 and the fourth odd integer is at most 26 less than the sum of the first and the third odd integers, which inequality represents the situation. Okay, so I've actually seen this type of problem before. So this isn't like a new format of a problem, but let's start off with making a list. Okay, so we have x, that's our first odd integer, right? We're told that the first integer is represented by x, and let's like use like a random odd integer, so like 3. To go to the next odd integer, which is like 5, you have to add by 2, right? So it'll be x plus 2. Your next integer is going to be 2 more after that, so it's going to be from starting from x, it's going to be plus 4, right? So if 3 is our x, if we're saying 3 is our x, to get to 7, you have to do plus 4, right? Hopefully you see a pattern. And so for our fourth integer, it's going to be x plus 6. Okay, so this is how it's going to look like. It's just skipping over the even, integer and giving us the odd integers. Okay? And now we're saying the product, so 12 times, or it looks like they're doing it like this, right? 12 times the fourth odd integer, which is this, is at most 26. Okay, so at most is less than or equal to. The reason why it's less than or equal to, you can think of it like the biggest number you can get to is 26, right? Because less than or equal to is saying less than or, equal to some number, right? So at most it's equal to a number, and we're saying is at most. So like that's like it's hard to explain, but you should just know like if it says at most it's less than or equal to. Right? Hopefully you understand that. And now we're saying that it's 26 less than the sum of the first and the third odd integers. So the first integer is x plus 4, right? Minus 26. And you can make it like this, make it a little bit prettier. But you should notice that it's going to be a, right? I mean, it's literally the exact same one that we got. X plus 4 minus 26. So yeah. If you didn't know that, though, again, you can eliminate these two, and it's kind of, a 50-50 shot here. But plus 3 wouldn't make much sense. Plus 3, like if we're saying 3 is our x, if we add plus 3 to that, it gets us an even number, which is something we don't want. So that doesn't make sense. So it's a for that reason. This one I'll kind of have to do some rearrangement, but I'll come back to that one for now. This one, the table shows 3 values for... Okay, so this one seems hard because you have like constants in your x's, but it really isn't if you know what to do. 21, 15. And now what you want to do is just pick a random number for s. So like I'll pick 4 or something. And essentially, it shouldn't matter what value of s it is, right? It shouldn't matter. If you graph any of these, it should always be the same regardless of what s is, right? So if we choose like s plus 3y equals 18s, as you can see, like maybe sometimes they'll be the same, but they won't always be the same. So it's not this one, because we're saying which of the following represents this relationship. So like that means for every value of s, it should be the same like equation. So it's not a. Let's try with the b. Plus sy equals 18s. Oh yeah, it's b. Like as you can see, like it, like regardless of, regardless of the s value, it's always going to be the same. It doesn't matter what the s value is, it's always going to be the exact same. So it's b. All right, almost done. In the system of equations k is a constant, the system has exactly one distinct real solution. What is the value of k? So let's graph this. I think I probably know what format it's going to be in. Yeah, I already know. So it's going to be like a quadratic, and we're trying to find when it touches the vertex pretty much, because that's going to be the only time like a line touches the quadratic one time. Minus 5x. Now let's just set a slider to k. Let me see if I graphed it. Yeah. So now we just want to move it. Let me change the boundaries real quick. Let me zoom in real close here. So it looks like it's in between 17 and 18. So let's try 17.5. Oh yeah. It's 17.5. So yeah. Moving on from that one. Also, quick tip, by the way, for these values, it's usually going to either be, for like these slider questions, it's always going to either be a whole number or like a pretty decimal number. It won't ever be like 0.43 or something. It's going to be like 0.5, 0.2, maybe 0.7. Like, it's just going to be like a good decimal. If it's in between two whole numbers, it's going to be like a good decimal you can turn into a fraction. Oh, this one's super easy. X plus 6. F of 4. It's 5. So the area of a rectangular banner is 2,661 square inches. The banner length X is the banner's length x is in inches is 24 inches longer than its width in inches. Which equation represents this situation? Okay, so the area of a rectangle is length times width, right? So we're told that our length is x. Let me take that away. And we're told that our width is, or we're told that our length is 24 inches longer than its width, meaning our width is 24 inches longer, or 24 inches shorter than our length, which is x. So I'm gonna just say x minus 26. Okay. They try to confuse you. They try to make you think like, oh, you need to add 26 to x, but we're told explicitly that length is x. You can't change that. It's x. So that must mean that w is actually x minus 26. Okay, so hopefully that makes sense. And so what we're left with here is sort of this equation where it's x minus 26, right? So this is, we're essentially doing length times width, and that's going to be equal to this, where we're already told the area of it. And so now we just need to graph these ones, see which one gets us the same like lines, and we're good. So 0 minus x squared minus 24x minus this. That looks to be it. Let me confirm that. Oh, it's not it. Okay. Good thing I checked. I would have definitely picked that on test day, but is this it? I don't even think it grabbed because it's, I don't know, maybe it's a, I don't know. I just know it's wrong. Is that it? Oh wait, I accidentally made this 26. That's why. So x minus 24 is this one. I think this one's it. I think C is it. Yeah, definitely. Yeah, it's C. So it's x squared minus 24 minus 2, 6, 6, 1. I accidentally made this 26 instead of 24. Move on. Same with this one. I'll have to do some writing on my notebook and try to explain it along the way. Okay. I actually love this type of question. It's actually really cool. So 28x plus 24y. It's a standard system of equation problem. Where's my second? Oh, it's the, okay. It's infinitely many solutions, but that's beside the point. So it's essentially asking whatever the r is. The r could be anything. It has to always be on this line. Okay, it has to, like, regardless of whatever r it is. Maybe like, you know, there's a r that has, that matches one or two of these problems, right? Like maybe it's, I don't know, maybe there's just an r that matches one of these problems, but it doesn't matter. It has to be for all r's, like all numbers. Okay, so like it says right here for each real number r. So just graph your point here. 6r 7 plus 5/7, and then just add a slider. And like this one's already wrong because this one's not even on it, but like it has to be true for all values of r. Like this value right here, or like yeah, like this value right here looks to be on it, but it doesn't matter. It has to be all values of r, is what I was saying. But like this one's not it because it's just, yeah, it's not true. So let's try B. 7r/6 plus 5/6. Okay, that one's just not it already. Let's try this next one. Plus 5 minus r/4 plus 20. Where's this one? Oh no, it's way up there. It's not that one either. Minus 6r/7 plus 5/7 r. Looks to be good. Oh yeah, that one's gonna be it regardless. Yeah, as you can see, like it's always gonna be on that line. So yeah, that's D. cost of renting a carpet cleaner is $52 for the first day and $26 for each additional day. Which of the following functions gives the cost in dollars of renting the carpet cleaner for D days where D is a positive integer? Okay, this is what I'll say about this question. This is a very common question. Okay, this question appears quite a bit, so really pay attention to this one because I've actually seen this quite a lot. Okay, so 52 for the first day. All right, that's just going to always stay the same. It's going to be 52 for the first day. Okay, and then we have to take into account our other days, right? So some of you may think this is the correct answer right here, 52 plus 26D. But as you can see, like, B is going to be the wrong answer, okay? Because essentially what you're doing is you're not taking into account, like, if we have 10, like, for example, if we have, say, 10, D is 10, you're not taking into account that you have essentially two different rates. You have your first day and you have your every day after that, okay? So we already have our 52 here accounted for. So whatever our D is, we have to subtract 1 from it. Because we're essentially saying, like, get rid of that first day because our first day is already accounted for here, right? So get rid of that first day, and then we're good. All right, this is our answer. So you want to kind of just distribute this, and if you distribute that, you get 26D, and then you get 26 or negative 26. You subtract 52 minus 26 is, I think, just 26. Yeah. And so what we're left with is 26D plus 26, which is just A. And this problem, like, appears quite a bit. Like, it appears a lot on one prep, so just make note of that, okay? So the speed of a vehicle is increasing at a rate of 7.3 meters per second squared. What is the rate in miles per minute squared? Okay, so for these ones, I would do it on my notebook, but I don't have a notebook. Let me just write it here in Desmos. So always with these conversions, I like to just write what it is. Okay, so it's meters per second squared. And now they give us miles. Okay, so they give us miles, and we want to cancel out the meters, and we want to use miles. So how do we cancel out the meters? Well, we have to have the meters in our denominator for our next, like, value we're multiplying by, right? It's kind of the same logic if you do, like, 2 times 4 over 2, 8, like, the 2's cancel, right? So it's kind of that same logic. So we have 1 mile, and then we have that equals 1,609 meters. And so the meters will cancel, right? And so now what our unit will be, it will be miles, or, well, it'll be mile over second squared. But we want it to be minute squared, right? And it's sort of the same logic here, but this time we have to have seconds on in the numerator to cancel out the seconds here. So we have 70 seconds is 1 minute, and they don't give you this, but you should know that intuitively. 1 minute, but we're still not done because we want this in. This will only, like, if we do it like this will only cancel out one of the s's, right? Because this is s squared, so we need to square this itself. Okay, and so what that will leave us with is the seconds will cancel, and then we'll get minutes squared in the denominator, and then we'll have miles in the numerator, so then we'll have miles per minute squared. So this gets us our full answer. So now we just need to multiply with the actual numbers, right? So we have 7.3 times 1 over 609 times, it was 60 squared. Technically it'll be like over 1, but 1 squared is just 1. So we get 16.3, and the closest to that is B. Okay. For these next ones, I'm going to try to go, I don't know, I'm going to have to write some down because I can't really do it in my head, but I'll try to explain it as much as I can. Or maybe not. Let me pull up the reference sheet. So we have a cone here. This is our cone. Let me write our volume. So our volume is 1 over 3 pi r squared h. And as you can kind of see for this, I had to kind of rush this, but a right circular cone has this volume, and the area of its base is this. What is the slant height? So the area of its base is this in particular, and as you can see here, the base is just a circle, right? And the area of a circle is this, right? And the reason they want to give you that is because you can find the radius off of that. So you can say pi r squared, right? And we'll just put this in regression format, is equal to this, 929 pi. So our r is 77. So keep note of that. Our r is 77. Okay. And so with that, we can use that to find the h of this, right? Because we're told the volume of that. So we have here 1 over 3 pi 77 squared h. We don't know h, but this is equal to 148 pi. And so now we have our r and we have our h, right? But it wants the slant height. You might think it's 36. It's not 36. What we're doing when we're finding 36 is we're finding this height right here, right? We're finding the h, like the height, the actual height of the cone. But it wants the slant height. The slant height, right? It wants the slant height. The slant height is this little area right here. Okay? It's essentially just, if you could see it, it's basically the Pythagorean theorem, right? Our r and our h are the two legs, and it wants the hypotenuse of that. So we do that by, we can just do it via regression as well. So 36 squared plus 77 squared is c squared. C squared is 85. Okay. Okay, so this one I have to rewrite it, so that's kind of why I rushed it, but it's not a hard question. Okay. So let me just rewrite it here in my notebook. This will take a while, so give me a second. X plus 2 over 7 5x plus 2 7. And then ky is, yep. Sorry about my little rambling. I have to just kind of focus here. I don't have that much time. Okay. All right. So just know for this value up here, if you rearrange it into just the standard y equals format, it's going to be something like this, where I'm too lazy to distribute, but it's going to be negative 2 over 5. And again, I could be wrong here. I don't have that much time. But you have this, right? For this one up here, if you rearrange it. Up here, you have y equals negative gx over k. And you have plus 5 over 2. And you have k down here. And we're told that these are infinitely many, so we can just set them equal to each other. So we can just say 5 over 7, negative 2, right, as a regression, by the way. So negative 2, 5, x1 plus 2 over 7. This is equal to this value right here, so g x1 over k plus 5 over 2k. And we have to set x1 to some random values. Okay. And so now we're told that we're given the values of g and k, and they're that, which is 2 over 7. Okay, so again, your steps here, rearrange these into y format and just set them equal to each other, because infinitely many solutions just means that they're equal to each other. And you can just make a regression, then boom, you're done. Okay. Hopefully I can do this last one fast. Okay, so we have a triangle, x, y, z. God, my pencil's failing on me. Okay, I need to get another pencil. Oh, this is bad. All right, got a new pencil. Okay, so we have, oh my God, don't tell me this one doesn't work as well. All right, we got a pencil that works. Thank God. All right, so we have let's see here. So y is a right. So y is a right angle. X, z, and don't worry, I'll explain it after I'm done here. So point P lies on xz. Xz. So point P. YZ. Okay, and point Q lies on. So Q. So PQ is parallel to XY. If the measure of XZY if the measure of XZY XPQ so Z, okay, so up here is 63. This is 90. XPQ, okay. All right. I think I got it. Maybe just in time. So 180 minus our right angle, minus 63 is 27. So, okay, so let me see. I wish there was like a drawing feature. Is there a drawing feature on Mac? I don't know. I don't think so. But essentially, you're supposed to draw a right triangle, and they want like a parallel. I think I'll just draw it in notes or something. But that's the only one I think I gotta explain because it's kind of hard to say it in words. But let me see what I got here. Okay, we missed one. Which one was the one I missed? I always miss like one. It was this one. All right, guys. So I wanted to go over the two problems that I got wrong, just because I was kind of rushing it. This first problem, I shouldn't have gotten wrong. I don't know what I did. I think I got it like mixed up or something. But like I was saying, my logic was right. But again, I just think that I rushed it or something. So we have this problem, x squared. Let me check here. Minus 24x plus, minus 2661, and that's equal to 0. Right, and again, I keep doing this mistake. I think it's like 20. I think that is 26, but it's actually 24. As you can see now, they are literally the exact same line. Okay, so I think it was just a silly mistake on my part. Shouldn't have done that, my bad. All right, guys, so here I have a little whiteboard I found online. So I, like I was saying, I was kind of rushing it, but if we go here, we're told that we have a triangle XYZ. So let's just, and also make note of this. Angle Y is a right angle, so I can, hopefully with the amount of time we have now, I can hopefully explain it easier to you and not mess up. So we have this triangle. It's a right triangle, right? It's a right triangle. Forget how bad it looks. It's, so we have our right triangle is Y. Okay, we're told that right here. Y is a right angle. So let's call this X. Let's call this Z. Okay, so X, Y, and Z. Then we're told point P lies on XZ. So I don't know, let's just choose like right here. This is going to be P. Okay. And then we're told that point Q lies on YZ such that PQ is parallel to XY. So point Q lies on YZ such that if we draw a line between Q and P, it's parallel to this line. Okay, so they have the same slope, but they never touch. So that's kind of what they mean. All right, and now we're told that, what are we told? The measure XZY is 63. So XZY is this angle right here. So this is 63. So now it's asking, what is the measure of angle XPQ? So it wants XP, so it wants this value right here, Q. And so what I was thinking at first, I thought it said XPZ or something like that. I don't know. I don't know what I was thinking. It was spur of the moment, but essentially I figured like this is, these angles are the same. It's sharing the same angle, so it just wants this angle right here. But it actually wants this angle right here. And funnily enough, that's actually not even, that's pretty easy to solve, okay? So what you have to realize here is that they're similar triangles, meaning that they'll have, so like we have this big triangle, right? We have this big triangle. God, that is so terrible. Ignore that. But we have that triangle, and we have this smaller triangle. Okay, and they share an angle, and as you can tell, this is a right angle. So that means that these are literally the exact same triangle. It's just that they're similar, meaning that they have the exact same angles, but they have different, like, obviously lengths of their sides. So here, what you can do is you can realize that this is going to be 63, right? Both of these have 63. This angle right here for the smaller triangle is going to be 90 as well, right? So this angle right here is going to be 90 as well, right? Meaning that this value, so this is kind of where I was getting a little bit confused here, meaning that this value, oh my God, this is so cluttered, but this value right here is going to be 180 minus 63 minus 90, right? And that gets us whatever, I think it was, I picked 26. What was it, 26 that I said? Or 27. Okay, 27. So now we have this value, okay, which is going to be pretty close to what our desired value is in terms of where they are located. We want XPQ. Okay, so we want XPQ, this value right here, which is fine. So now what you have to realize is, okay, so we have this value and we want this value. And they're both on a straight line. So what you can do is you can take this value, you can do 180, right? Because 180 is the measure of the angle of a straight line. So 180 minus this value right here, okay, is going to be equal to this. All right, so let me try to like draw it out better. So like what I mean is, if this entire thing is 180, right? Because that's the measure of a flat sort of line, and we're told that this is 27. We found that this is 27. We can do 180 minus 27, right? And you'll realize it gets us 153. Okay, so I wasn't even that far off from getting it right, but I guess I don't know. I just spare of the moment. It was just I got it wrong. So two silly mistakes on my part. Um, but yeah, hopefully you learned something, right? I think that James Liu, I think he did like four practice test four. Oh no, I think he did five, six, and eight, if I'm not mistaken. So next video, I think I'll do four. Right, I'll pump that out like tomorrow or something. But hopefully you learned something from this. Um, yeah.